Units. 1.1 Introduction. Imagine you had to make curtains and needed to buy fabric. The shop assistant would need to know how much fabric you needed. Telling her you need fabric 2 wide and 6 long would be insufficient. You have to specify the unit, i.e., 2 meters wide and 6 meters long. Without the unit, the information is incomplete and the shop assistant would have to guess. If you were making curtains for a doll's house, the dimensions might be 2 centimeters wide and 6 centimeters long. It is not just lengths that have units, all physical quantities have units, e.g., time, temperature, distance, h. Definition: physical quantity. A physical quantity is anything that you can measure. For example, length, temperature, distance, and time are physical quantities. 1.2 Unit systems. 1.2.1 SI units. We will be using the SI units in this course. SI units are the internationally agreed upon units. Historically, these units are based on the metric system which was developed in France at the time of the French Revolution. Definition: SI units. The name SI units comes from the French aim international d'unités, which means International System of Units. There are 7 base SI units. These are listed in Table 10.1. All physical quantities have units, which can be built from these 7 base units. These 7 units were defined to be the base units. So, it is possible to create a different set of units by defining a different set of base units. These 7 units are called base units because none of them can be expressed as combinations of the other 6. This is identical to bricks and concrete being the base units of a building. You can build different things using different combinations of bricks and concrete. The 26 letters of the alphabet are the base units for a language like English. Many different words can be formed by using these letters. 1.3 Chapter 1. Units. Base quantity name symbol. Length meter m. Mass kilogram. Time second s. Electric current ampere A. Temperature Kelvin K. Amount of substance mole mho. Luminous intensity candela CD. Table 1.1 SI base units. 1.2.2 The other systems of units. The SI units are not the only units available, but they are most widely used. In science, there are 3 other sets of units that can also be used. These are mentioned here for interest only. CGS units. In the CGS system, the meter is replaced by the centimeter and the kilogram is replaced by the gram. This is a simple change, but it means that all units derived from these 2 are changed. For example, the units of force and work are different. These units are used most often in astrophysics and atomic physics. Imperial units. Imperial units arose when kings and queens decided the measures that were to be used in the land. All the imperial base units, except for the measure of time, are different to those of SI units. This is the unit system you are most likely to encounter if SI units are not used. Examples of imperial units are pounds, miles, gallons, and yards. These units are used by the Americans and British. As you can imagine, having different units in use from place to place makes scientific communication very difficult. This was the motivation for adopting a set of internationally agreed upon units. Natural units. This is the most sophisticated choice of units. Here the most fundamental discovered quantities, such as the speed of light, are set equal to 1. The argument for this choice is that all other quantities should be built from these fundamental units. This system of units is used in high-energy physics and quantum mechanics. 1.3 Writing units as words or symbols. Unit names are always written with a lowercase first letter. For example, we write meter and liter. The symbols or abbreviations of units are also written with lowercase initials, for example M for meter and for liter. The exception to this rule is if the unit is named after a person, then the symbol is a capital letter. For example, the Kelvin was named after Lord Kelvin and its symbol is K. If the abbreviation of the unit that is named after a person has 2 letters, the second letter is lowercase, for example HZ for Hertz. Exercise, naming of units. For the following symbols of units that you will come across later in this book, write whether you think the unit is named after a person or not. 2. Chapter 1. Units 1.3. 1. J. Joule. 2. Liter. 3. N. Newton. 4. Mole. 5. C. Coulomb. 6. Lm. Lumen. 7. M. Meter. 8. Bar. 3. 1.4 Chapter 1. Units. 1.4 Combinations of SI base units. To make working with units easier, some combinations of the base units are given special names. But it is always correct to reduce everything to the base units. Table 10.2 lists some examples of combinations of SI base units that are assigned special names. Do not be concerned if they formulae look unfamiliar at this stage. We will deal with each in detail in the chapters ahead as well as many others. It is very important that you are able to recognize the units correctly. For instance, the Newton N is another name for force, which is defined as kilogram meter per second squared. Kilogram ms घटाव 2, while work is measured in kilogram meter squared per second squared, kilogram m2 s घटाव 2, and is called the joule J unit expressed in name of quantity formula base units combination. Force ma kilogram ms घटाव 2 n Newton. Frequency T1 s घटाव 1 Hertz. Work Fs kilogram m2 s घटाव 2 J joule. Table 1.2 Some examples of combinations of SI base units assigned special names. Important: when writing combinations of base SI units, place a dot between the units to indicate that different base units are used. For example, the symbol for meters per second is correctly written as ms घटाव 1 and not as ms घटाव 1 or 1.5 rounding, scientific notation and significant figures. 1.5.1 rounding off. Certain numbers may take an infinite amount of paper and ink to write out. Not only is that impossible, but writing numbers out to a high accuracy, many decimal places, is very inconvenient and rarely gives better answers. For this reason, we often estimate the number to a certain number of decimal places. Rounding off or approximating a decimal number to a given number of decimal places is the quickest way to approximate a number. For example, if you wanted to round off to 6,525,272 to 3 decimal places, then you would first count 3 places after the decimal. 2,652, 5,272. All numbers to the right of are ignored after you determine whether the number in the third decimal place must be rounded up or rounded down. You round up the final digit, make the digit 1 more if the first digit after the was greater or equal to 5, and round down, leave the digit alone otherwise. So, since the first digit after the is a 5, we must round up the digit in the third decimal place to a 3, and the final answer of 6,525,272 rounded to 3 decimal places is 2,653. Worked example 1, rounding off. Question: round off pi equals 3, 141,592,654 to 4 decimal places. Answer. Step 1. Determine the last digit that is kept and mark the cutoff with pi equals 3, 14, 15, 92,654. Step 2. Determine whether the last digit is rounded up or down. The last digit of pi equals 3, 14, 15, 92,654 must be rounded up because there is a 9 after the. 4. Chapter 1. Units 1.5. Step 3. Write the final answer. Pi equals 3, 14, 16 rounded to 4 decimal places. 5. 1.5 Chapter 1. Units. Worked example 2, rounding off. Question: round off 9, 191,919 to 2 decimal places. Answer. Step 1. Determine the last digit that is kept and mark the cutoff with 19. Step 2. Determine whether the last digit is rounded up or down. The last digit of 9, 19 must be rounded down because there is a 1 after the. Step 3. Write the final answer. Answer equals 9, 19 rounded to 2 decimal places. 1.5.2 Error margins. In a calculation that has many steps, it is best to leave the rounding off right until the end. For example, Jack and Jill walk to school. They walk 0.9 kilometers to get to school and it takes them 17 minutes. We can calculate their speed in the following 2 ways. Method 1, Method 2. Change 17 minutes to hours, change 17 minutes to hours. Time equals 6017, time equals 6017. Equals 0, 283,333,333 kilometers equals 0, 28 kilometers. Speed equals distance, speed equals distance. 0, 9 times 0, 9 time. Equals 0, 28,333,333 equals 0, 28. equals 3, 176,470,588 equals 3, 214,285,714. 3. 18 kilometers हर घटाव 1 3, 21 kilometers हर घटाव 1. Table 1.3, rounding numbers. You will see that we get two different answers. In method 1 no rounding was done, but in method 2, the time was rounded to 2 decimal places. This made a big difference to the answer. The answer in method 1 is more accurate because rounded numbers were not used in the calculation. Always round off only your final answer. 1.5.3 Scientific notation. In science, one often needs to work with very large or very small numbers. These can be written more easily in scientific notation in the general form d guna 10e, where d is a decimal number between 0 and 10 that is rounded off to a few decimal places. E is known as the exponent and is an integer. If e greater than 0, it represents how many times the decimal place in d should be moved to the right. If e less than 0, then it represents how many times the decimal place in d should be moved to the left. For example, 324 guna 103 represents 3240, the decimal moved 3 places to the right, and 324 guna 10 घटाव 3 represents 0.0324, the decimal moved 3 places to the left. If a number must be converted into scientific notation, we need to work out how many times the number must be multiplied or divided by 10 to make it into a number between 1 and 10. I.e. the value of e, and what this number between 1 and 10 is, the value of d. We do this by counting the number of decimal places the decimal comma must move. For example, write the speed of light in scientific notation to 2 decimal places. The speed of light is 299,792,458 meters s घटाव 1. First, find where the decimal comma must go for 2 decimal places. To find d, and then count how many places there are after the decimal comma to determine e. 6. Chapter 1. Units 1.5. In this example, the decimal comma must go after the first 2, but since the number after the second 9 is 7, d equals 3, 00, e equals 8 because there are 8 digits left after the decimal comma. So the speed of light in scientific notation to 2 decimal places is 300 guna 108 meters s घटाव 1. 7. 1.6 Chapter 1. Units. 1.5.4 Significant figures. In a number, each non-zero digit is a significant figure. Zeros are only counted if they are between two non-zero digits or are at the end of the decimal part. For example, the number 2000 has one significant figure, the 2, but 2000 has 5 significant figures. You estimate the number like this by removing significant figures from the number, starting from the right until you have the desired number of significant figures, rounding as you go. For example, 6827 has 4 significant figures, but if you wish to write it to 3 significant figures, it would mean removing the 7 and rounding up, so it would be 683. Exercise using significant figures. 1. Round the following numbers. 123,517 to 2 decimal places. B. 14,328 kilometers h घटाव 1 to 1 decimal place. C. 0.0954 m to 3 decimal places. 2. Write the following quantities in scientific notation. 10,130 pascals to 2 decimal places. B. 978, 15 meters s घटाव 2 to 1 decimal place. C. 0.0012568 to 3 decimal places. 3. Count how many significant figures each of the quantities below has. 2,590 kilometers. B. 12,305 meters. C. 7,800 kilograms. 1.6 Prefixes of base units. Now that you know how to write numbers in scientific notation, another important aspect of units is the prefixes that are used with the units. Definition: prefix. A prefix is a group of letters that are placed in front of a word. The effect of the prefix is to change meaning of the word. For example, the prefix "un" is often added to a word to mean not, as in unnecessary, which means not necessary. In the case of units, the prefixes have a special use. The kilogram is a simple example. 1 kilogram is equal to 1000 grams or 1 guna 103 grams. Grouping the 103 and the g together, we can replace the 103 with the prefix k, kilo. Therefore the k takes the place of the 103. The kilogram is unique in that it is the only SI base unit containing a prefix. In science, all the prefixes used with units are some power of 10. Table 10.4 lists some of these prefixes. You will not use most of these prefixes, but those prefixes listed in bold should be learnt. The case of the prefix symbol is very important. Where a letter features twice in the table, it is written in uppercase for exponents bigger than 1 and in lowercase for exponents less than 1. For example, M means mega 106 and M means milli 10^3. Art. Chapter 1. Units 1.6. Prefix symbol exponent. Prefix symbol exponent. Yata y1024 yocto y10^24. Zeta z1021 zepto z10^21. Xa 1018 atto a 10^18. Peta p1015 femto f10^15. Tera t1012 pico p10^12. Giga G109 nano n 10^9. Mega M106 micro 10^6. Kilo K 103 milli M 10^3. Hecto H102 centi C 10^2. Deca Da 101 deci D 10^1. Table 1.4 Unit prefixes. Important, there is no space and no dot between the prefix and the symbol for the unit. Here are some examples of the use of prefixes. 40,000 meters can be written as 40 kilometers, kilometer. 0.001 g is the same as 1 guna 10^3 grams and can be written as 1 milligram, milligram. 2. 5 guna 106 n can be written as 2.5 meganewtons, meganewton. 250,000 A can be written as 250 kiloamperes, kiloampere or 0.250 megaamperes, megampere. 0.0075 S can be written as 75 nanoseconds, nanoseconds. 3 guna 10^7 moles can be rewritten as 0.3 guna 10^6 moles, which is the same as 0.3 micromole, micromole. Exercise, using scientific notation. 1. Write the following in scientific notation using table 10.4 as a reference. A. 511 megavolts. B. 10 C. C. 5 micrometers. D. 250 nanometers. E. 0.035 Hg. Do. Write the following using the prefixes in table 10.4. A. 1602 guna 10^19 C. B. 1992 guna 106 J. C. 598 guna 104 N. D. 25 guna 10^4 A. E. 0.0075 guna 106 meters. 9. 1.7 Chapter 1. Units. 1.7 The importance of units. Without units, much of our work as scientists would be meaningless. We need to express our thoughts clearly, and units give meaning to the numbers we measure and calculate. Depending on which units we use, the numbers are different. For example, if you have 12 water, it means nothing. You could have 12 milliliters of water, 12 liters of water, or even 12 bottles of water. Units are an essential part of the language we use. Units must be specified when expressing physical quantities. Imagine that you are baking a cake, but the units, like grams and milliliters, for the flour, milk, sugar and baking powder are not specified. Activity, investigation, importance of units. Work in groups of 5 to discuss other possible situations where using the incorrect set of units can be to your disadvantage or even dangerous. Look for examples at home, at school, at a hospital, when traveling and in a shop. Activity, case study, the importance of units. Read the following extract from CNN News the 30th of September 1999 and answer the questions below. NASA, human error caused loss of Mars orbiter November 10, 1999. Failure to convert English measures to metric values caused the loss of the Mars Climate Orbiter, a spacecraft that smashed into the planet instead of reaching a safe orbit. A NASA investigation concluded Wednesday. The Mars Climate Orbiter, a key craft in the space agency exploration of the Red Planet, vanished on the 23rd of September after a 10-month journey. It is believed that the craft came dangerously close to the atmosphere of Mars, where it presumably burned and broke into pieces. An investigation board concluded that NASA engineers failed to convert English measures of rocket thrusts to Newton, a metric system measuring rocket force. 1 English pound of force equals 445 newtons. A small difference between the two values caused the spacecraft to approach Mars at too low an altitude, and the craft is thought to have smashed into the planet's atmosphere and was destroyed. The spacecraft was to be a key part of the exploration of the planet. From its station about the Red Planet, the Mars Climate Orbiter was to relay signals from the Mars Polar Lander, which is scheduled to touch down on Mars next month. The root cause of the loss of the spacecraft was a failed translation of English units into metric units and a segment of ground-based, navigation-related mission software, said Arthur Stevenson, chairman of the investigation board. Questions. 1. Why did the Mars Climate Orbiter crash? Answer in your own words. 2. How could this have been avoided? 3. Why was the Mars orbiter sent to Mars? 4. Do you think space exploration is important? Explain your answer. 1.8 How to change units. It is very important that you are aware that different systems of units exist. Furthermore, you must be able to convert between units. Being able to change between units, for example, converting from millimeters to meters, is a useful skill in science. Thus, Chapter 8. Units 1.8. The following conversion diagrams will help you change from one unit to another. Guna 1000 Guna 1000. Km. Bhag 1000 Bhag 1000. Figure 1.1, the distance conversion table. If you want to change millimeter to meter, you divide by 1000, follow the arrow from to m. Or if you want to change kilometer to millimeter, you multiply by 1000 Guna 1000. The same method can be used to change milliliter to liter or kiloliter. Use figure 10.22. Change volumes. Guna 1000 Guna 1000. M33K3. CMM. DM. Bhag 1000 Bhag 1000. Figure 1.2, the volume conversion table. Worked example 3, conversion 1. Question, express 3800 millimeters in meters. Answer. Step 1, find the two units on the conversion diagram. Use figure 10.1. Millimeter is on the left and meter in the middle. Step 2, decide whether you are moving to the left or to the right. You need to go from to m, so you are moving from left to right. Step 3, read from the diagram what you must do and find the answer. 3800 millimeters bhag 1000 equals 8 meters. Worked example 4, conversion 2. Question, convert 56 kilograms to G. Answer. Step 1, find the two units on the conversion diagram. Use figure 10.1. Kilogram is the same as kilometer and gram the same as meter. Step 2, decide whether you are moving to the left or to the right. You need to go from kilogram to G, so it is from right to left. Step 3, read from the diagram what you must do and find the answer. 56 kilograms Guna 1000 equals 4560 grams. 11. 1.9 Chapter 8. Units. 1.8.1 to other useful conversions. Very often in science you need to convert speed and temperature. The following two rules will help you do this. Converting speed. When converting kmh/1 to ms/1, you divide by 6. For example, 72 kilometers h/1 bhag 6 equals 20 meters s/1. When converting ms/1 to kmh/1, you multiply by 6. For example, 30 meters s/1 guna 6 equals 108 kilometers h/1. Converting temperature. Converting between the Kelvin and Celsius temperature scales is easy. To convert from Celsius to Kelvin, add 273. To convert from Kelvin to Celsius, subtract 273. Representing the Kelvin temperature by Tk and the Celsius temperature by 2C. Tk equals to C joe 273. 1.9 A sanity test. A sanity test is a method of checking whether an answer makes sense. All we have to do is to take a careful look at our answer and ask the question, does the answer make sense? Imagine you were calculating the number of people in a classroom. If the answer you got was 1 million people, you would know it was wrong. It is not possible to have that many people in a classroom. That is all a sanity test is. Is your answer insane or not? It is useful to have an idea of some numbers before we start. For example, let us consider masses. An average person has a mass around 70 kilograms, while the heaviest person in medical history had a mass of 635 kilograms. If you ever have to calculate a person's mass and you get 7,000 kilograms, this should fail your sanity check. Your answer is insane and you must have made a mistake somewhere. In the same way, an answer of 0.01 kilograms should fail your sanity test. The only problem with a sanity check is that you must know what typical values for things are. For example, finding the number of learners in a classroom, you need to know that there are usually 20 to 50 people in a classroom. If you get an answer of 2500, you should realize that it is wrong. Activity, the scale of the matter. Try to get an idea of the typical values for the following physical quantities and write your answers into the table. Category: quantity, minimum, maximum. Mass, people height, speed of cars on freeways, transport speed of trains, speed of aeroplanes, distance between home and school, general thickness of a sheet of paper, height of a doorway. 1.10 Summary. 1. You need to know the 7 base SI units as listed in table 10.1. Combinations of SI units can have different names. 12. Chapter 1. Units 1.10. 2. Unit names and abbreviations are written with lowercase letter unless it is named after a person. 3. Rounding numbers and using scientific notation is important. 4. Table 10.4 summarizes the prefixes used in science. 5. Use figures 10.1 and 10.2 to convert between units. 13. 1.11 Chapter 1. Units. 1.11 End of chapter exercises. 1. Write down the SI unit for each of the following quantities. A. Length. B. Time. C. Mass. D. Quantity of matter. 4. 2. For each of the following units, write down the symbol and what power of 10 it represents. A. Millimeter. B. Centimeter. C. Meter. D. Kilometer. 4. 3. For each of the following symbols, write out the unit in full and write what power of 10 it represents. A. Micro G. B. mg. C. Kilogram. D. mg. 4. 4. Write each of the following in scientific notation, correct to 2 decimal places. A. 0.0000123 N. B. 417 million kilograms. C. 246,800 A. D. 0.088 ton. 4. 5. Rewrite each of the following using the correct prefix in 2 decimal places where applicable. A. 0.00123 N. B. 417 million kilograms. C. 246,800 A. D. 0.088 ton. 4. 6. For each of the following, write the measurement using the correct symbol for the prefix and the base unit. A. 1.08 microseconds. B. 1000 milligrams. C. 2 megameters. D. 11 nanoliter. 4. 7. The Concorde is a type of aeroplane that flies very fast. The top speed of the Concorde is 844 kilometers per ghatav 1. Convert the Concorde's top speed to ms ghatav 1. 3. 8. The boiling point of water is 100 C. What is the boiling point of water in Kelvin? 3. Total equals 30. 14. Part I. Chemistry. 15. Chapter 2. Classification of matter, grade 10. All the objects that we see